SwayamPrabha. Digital India. Educated India.
Now let me again take you through the various journeys of the concerns. Now we are very clear. We have three things. See, we have the collaborative model. We have the valleys of death. So those are the stages and the valleys. And then we have the sort of concerns, which are the three concerns, which are the 7 concerns. So with these three things, an amalgamation, my last notes is about the amalgamation. Using the amalgamation of all the three, you will have an innovation journey which will be, which will be very good, and there is very little chance of failure. So let me show you the first. Each C, I like to show you an example from our studio. The first C is actually the vein tracer. People actually go to give blood to banks, to the blood banks, and when you go to give blood to blood banks, there's a problem that you end up having, like serious problems, like multiple pricks if you're obese, or if your veins are, deep inside, you have a problem of things. So, this particular, vein tracer actually, basically can actually trace the veins because of infrared light, and it's a very simple product. We have, we worked a lot on the various design options. It's a student project, and now we have actually, tried to manufacture it ourselves. We built 20 pilot production pieces, and then finally we actually transferred the technology to a company which is very good in medical products called Colmed. So till I didn't do the transfer, the product was not going anywhere. So we now know that companies which are efficient in the next processes of marketing, distribution, network, and servicing, we need to take our products forward. So this product is there, in the market now. And we talk about the cause. The cause was, you should be able to see the veins so that people who come to donate blood don't get the pain. And this was identified by students by going to the blood banks. This is part of a course in IDC, and we took this forward. Let me show you the next project. This was not a course, but a project where one of my very good students worked on a problem for CRPF. CRPF commander Sadanand Date, who was also in 9/11, he was shot in 9/11 in the Kama hospital. He was the one who kept the terrorists at bay nearly for 30 minutes. He's the one who was very, very close to us. He talked a lot about the thing, and then he went to CRPF and he said, "Professors, you have to visit our site. You have to come and experience what our Jawans go through." So one of my colleagues, Professor Hemendra Arya, went to the field, and he came back, and every day, and we stay in the same building, every day he would tell me in the lift that, "Professor Chakravarti, we need to do something for the water." Because the biggest challenge for my CRPF Jawans is they have long duration errands, and during those errands they get extended, and they actually lose hydration, because water is the biggest problem. And actually the local population sometimes are very hostile, and they also poison the water sources. You can see how we came up with this wonderful concept completely by lot of interaction with the CRPF. Every stage our CRPF Jawans would come to IDC, we would go to their barracks, and it was unbelievable, because I myself thought, what is there in a water bottle? We can easily design and we can make it happen. But every detail in this water bottle, what you see, has been actually, there's an input from the CRPF Jawans. Let me quickly show you a small video on what the student made when she came up. So after the student project was over, we actually built the whole prototype, and then we took this forward. So now let me take you to this, interesting journey of the comprehension. I had another, student of mine called Avinash. Avinash was actually, doing his project with me, and we said, why don't people use solar ovens? And, and then we went and studied all the people using solar ovens. Very few people were there who were using solar ovens because it was a box type oven and you had to actually open the oven and it's very cumbersome. Let me quickly take you to Avinash, to his desk. He's our design head, and he's also working. You can see the that's Avinash, the type of models he's working on and the type of design. We've nearly come up with the pilot production now. Most of our colleagues now are actually working on development, and we will like to show you. We installed one in our studio, and Trupti, you can actually Trupti will open the oven and show you the type of oven it is. We built the convenience of bringing the oven into the house. So it's fitted in the window. So when you fit in the window, you have the convenience of opening from inside the house, and we use the best technologies on campus. We have technologies of thermal analysis. We have Professor from Energy Sciences, Professor Kedare and Professor Modi helping us with the dynamics and the working aspects. We have Professor Dusani and other colleagues from Material Science helping us with the coatings. We have professors from our design department itself helping us with how we can actually look at the shape and design. And the most important, we have our director, Professor Devang Kakkar, who would say, Chakravarti, we want this product to look great. It has to look like a contemporary consumer product. So that's what we see. In fact, even now, it's extremely hot. In weathers like Bombay, we can cook rice. And you can just imagine if you take this product to Jaipur or to Ahmedabad, it was really, really popular. And here, we are just using greenhouse effect. And there is special technology of rheology. I have my colleagues from IIT Delhi who are specialists in polymer science, and they help us with the double-walled polycarbonate, which is a special property of taking the heat waves inside and not letting any heat waves go out. And that's the reason, without any reflector, we are able to make this oven which is working. And it actually fits like a like window air conditioner, and it is very, very convenient to use. So now we are in the pilot production of this oven, and we're looking forward to take this to the market, and we're looking for technology transfer help in this. So now let me take you to the next C. I'm actually highlighting each C in this journey, where we are saying that we were looking at how we designed various projects for various aspects. This is a very, very tough and very interesting project we did for designing a palki for Vaishno Devi. And this palki is a very interesting story where we had to collaborate, and the check became very important here. What type of checklist we make for ourselves, and we had to go through multiple prototypes to come up with the final prototype. And I will like to show you the type of design we did. We collaborated with NITI. NITI was our ergonomics partner. They support us on design and ergonomics. We had support from Jindal again. They helped us in manufacturing and developing the product. And we also had our material people helping us with the stainless steel pipes. And what is interesting is a lot of people said, why don't you use plastics? Why don't you use resins? But we also have to look at the longevity of the product. We have to look at how the product will last. And now we are very, very happy to inform you that we did the pilot production. That has gone very well. And now we have 100 palkis in Vaishno Devi. So when you go next to Vaishno Devi, Mata Vaishno Devi shrine, you'll be able to ride one of the palkis if you're not able to walk up the hill. Let me show you the video which actually captures all aspects of collaboration, research. We had our structural engineering professor. The whole, the beauty of this design is that we had very good structural, support from our civil engineering professors, Professor Desai, who support us on this. And because of the structural support, we could actually reduce the weight to 34 kilos from, nearly 50 to 30, and every kilo counts in that terrain and then situation. So let me show you this video. It's a little longer, but we like to show you the video.
श्री माता वैष्णो देवी श्राइन में पहुंचने के लिए बहुत से साधनों का प्रयोग होता है और उन साधनों में पालकी एक बहुत महत्वपूर्ण साधन है और जिसका उपयोग जो है हमारे जो अशक्त और वृद्ध लोग हैं वो करते हैं। लेकिन इस पालकी को कैरी करने वाले पोर्टर्स की बहुत सी परेशानियां हैं क्योंकि उसका पालकी का वज़न काफ़ी होता है और 13 किलोमीटर के इस ट्रैक पे उसको ले करके जाना एक काफ़ी पेनफुल मैं कहूँगा कि काम है जिसको इम्प्रूव करने की ज़रूरत समझी गई।
Our role in this project was to do a very good user study, understand the needs of the porters very, very closely and come up with designs which will help them to reduce the drudgery.
While IDC put up a design, we came up with ergonomic studies, their biomechanics system, where the load is coming. We found the shoulder and back were two areas where the lower back was two areas where a load was very heavy, and we looked at how we can reduce that load by doing proper design.
The final design was lightweight and robust. We could reduce the weight to 34 kilos from around 50 to 54 kilos, and this made a large impact on the comfort of the porters. At the same time, we were very focused on the structural analysis of the palki, and we conducted the analysis that we managed to maintain very good structural stability and structural integrity in the design so that the palki can last long and it can be very safe.
Today I am very happy as these integrative efforts are being concluded, and final solution is emerged is lightweight, ergonomically designed, safety aspects are there, all the designs are structurally validated.
So we take our sort of, we get projects from our principal scientific advisor to the Prime Minister's office, and we've done, this project from there. We also have some very interesting projects. In the end, I want to show you how we took research-led innovation forward. That also we will show you slowly. So here we have, the same, I already discussed this at length, the fifth C, the conception. We have a very good idea of how we conceive this box, and we came forward with this round top on the box. I talked about this quite a bit in my 7 concerns for innovation. So we will now show you the crafting. Again, that's what I was saying, that you can see the comparison between the old and the new, and the final design is actually red, and nobody can mistake this product for the letterbox, and that was very, very important in the design journey. So we have learnt the hard way. Even doing so much work, we compromise on user studies sometime. We don't do the type of user study we need, where we need to go not convenient locations like you're in the city, you just go around in the city and ask for studies, but you look at a national level of user study and take things forward. And then, of course, my 7th C was a connection where we have a very good example of all our petrol pumps taking forward. So we are fortunate that for the last nearly 10 years we have set up a design innovation center. Thanks to our Ministry of Human Resource and Development, they have now set up 20 design innovation centers all over the country, and because of these design innovation centers we are able to do all these projects. We have a lot of projects on our, on our annual. We will not be able to discuss all, but I would like to, stop the lecture by showcasing one very important aspect of research-led innovation. We've not been doing much on that. The whole country is behind. We are very, very high end on research. We got one of the best agricultural researchers in the country, but where is our agriculture? We have some of the best researchers in our defense. Where is our equipment? We have some of the best nuclear scientists here who have done phenomenal work in nuclear science, but they want to give their technology out. We're not able to take this technology out from BRC. So BRC has approached us to do their application development and take things forward. So with all these things, I would like to show you before I go a very important model for innovation. We call it the sunflower model for innovation. After the animation, I'd like to speak to you about the model. Like the sunflower model, we have all the features and aspects of the design, like petals around the sunflower. And what is interesting is, like the sunflower looks towards the sun, our sunflower model should look towards the user. If I'm doing design, if I'm doing finance, all of them should be user friendly. For example, I can't make a product just because it's innovative, a very expensive product where the user can't afford it. So this sunflower model is a very interesting model where we actually see to it that we build a lot of features in our product. All the features actually look towards the user, because I don't have any feature, and the user is multitude. They're both end users, they're like manufacturing people, marketing people, and everybody is our user. So that convenience has to be built into our design basis. Now from here, I like to show you the research journey. After I finished my PhD in IIT Delhi, and we started the PhD program in Bombay, and we had this one student who joined. That student worked on something called typography, and in the typography he was working on the type design in palm leaves to type design in digital media and letterpress. So he was looking at the transitions, and during this work there was this special program where they said, why don't you look at there was a rupee symbol competition for the country from the Prime Minister's office, from the Reserve Bank. And here, we could see that this student worked for 8 months on this rupee symbol, and now this rupee symbol is launched, and he was selected out of thousands of entries which came for the rupee symbol. So what research can do to design and innovation is a very good example of our first PhD student in design innovation. And now he's a professor at the IIT Guwahati Design School, and he's the head of the department in the design school there. So that is not enough. When we worked with Bajaj Auto, we want to check up what is the aesthetic aspects, because we have this experience of the letterbox. So we actually did research for 7 years on something called the eye movement recorder. What do people look in products, and how do they look, and what are the aesthetic preferences? So these are the aesthetic preferences we looked at, and we designed, and taking the aesthetic preferences of auto rickshaw drivers, we designed this new auto rickshaw for them, which is mass produced and which is the next generation auto rickshaw. Unfortunately, this couldn't go to the market, and it's still on the drawing boards. Similarly, we worked with a nanotechnology department of IIT Bombay. Professor Ram Gopal Rao is currently the director of IIT Delhi. He set up this huge lab of nanotechnology in IIT, and I went to him and said, Professor Ram Gopal, I would like to work with you to use, to make productize your research. So this particular design, what you see over here, is a cardiac diagnostic unit. This diagnostic unit is very interesting. The sensor, which is a nano sensor, a nano cantilever, can detect problems in the heart 2 years before the heart attack can come. Isn't that fabulous? And then we built the whole model for them. It took us 6 to 7 months to build this model, and then the funding became 4 times once the professor showed this model to the funding agencies. And now there's a company called NanoSniff, incubated in IIT, to take this research forward into the market. And they also use it for explosive detections. They use it for various applications. And similarly, we have worked on with our professors from electrical engineering to develop 5G communication for our commandos. This is again the same Mr. Sadanand Date who requests us to work. Again, the design principles and the methodology we follow is the same. We build the prototypes within 6 months, and now this is under production. I would like to close this session by showing you this very interesting study which is on medical products. I was a very small part of this development. It's a medical product, and this is again from the Principal Scientific Advisor's office. A lot of funding had come to us for developing this mega prosthesis for cancer children. At the Tata Memorial Hospital, you have at least 10 cancer kids who come who have to be amputated because they can't afford a mega prosthesis. This is one of the most exotic materials using titanium. You have the molybdenum condyle, you have the HA collar, coating HA collar, and then you have the arms coming in. You can see the sections over here. So we had a consortium of doctors engineers and professors working together, and I will show you the film on how we developed this. And I'm extremely proud to tell you that this particular product now is under clinical testing in 7 hospitals, and we produced 14 processes right now, and they're under clinical trials. And after the clinical trials, the manufacturing will happen at NFTDC Hyderabad, and this product will go forward. It's a great example of collaborative innovation. It is actually 1/6 the price of any international process. And what is interesting is, when you do innovation today, you're not stuck with old data. The Stryker and the largest companies in the world are stuck with legacy. When you start new, and you can leapfrog people, the earlier companies. That's why startups are doing very well, and we must understand that that agility is very, very important to take things forward. So let me now quickly show you the video of the TKP.
Tata Memorial Center is a part of the Department of Atomic Energy, and you need mega prosthesis implants, and one of the crucial ones is in the knee. So we decided to bring together Dr. Agarwal, who is interested in this, but then we wanted a good mechanical engineering. That's why we got Dr. Ravi from IIT Bombay, and it was very clear that it has to be a non-ferrous metal alloy design. So we brought in the NFTDC from Hyderabad, Dr. Balasubramaniam, and this is an excellent example of how people with different competences can work together and then create a world-class product.
When Dr. Manish Agarwal had met Dr. R. Chidambaram, the principal scientific advisor to the Government of India, and that is when he shared with Dr. Chidambaram the fact that he had a wonderful idea of a project with a lot of societal implications.
Bone cancer had become curable with the chemotherapy. After he's cured of his bone cancer, the only problem that remains is going to be mechanical or prosthesis related. So we needed an Indian prosthesis which was high quality but which was still affordable to our patients, and that started our need.
So TKP is not just one product. Actually, it is a system of products. We have the main device in multiple components. Then we have surgical instruments, quite a number of them. And then we also later built a walking machine to test the joint for millions of cycles to make sure it is safe before human trials. Now the first versions of these were developed in OrthoCAD lab in IIT Bombay, and later on they were taken over by NFTDC Hyderabad.
We are making it by state-of-art computer-controlled processes using very high-quality materials and elaborate testing mechanisms, both for the input materials as well as for the final product. Above all, it has been tested in a knee simulator testing machine for over 10 million cycles. We are very confident that it would be superior product and it would restore much of the natural functions of the knee joint.
Our Indian patients, they will get the best possible implant and the best possible treatment at almost 1/4 the cost of what they have to pay for getting this important implant in their body for such a serious condition such as cancer.
The good part of this project is that every 3 months we had a very sincere, devoted type of meetings for the development of the prosthesis.
After the year 2012, there were a lot of changes in the guidelines and the law regarding the clinical trials, and I had been giving inputs regarding those.
It was a marvel of engineering which was to be implemented in human body.
We were able to develop further team of next generation of scientists and engineers. So a large number of youngsters in design, in manufacturing, in materials, and even junior surgeons.
we're looking at how we could redesign some of the armamentarium which is used to operate upon and put the process in the human body, as well as work on the packaging and making the whole product and the processes very user friendly and convenient for the doctors, as well as convenient for the systems to take this thing forward.
The seed of AutoCAD, the TKP project, which was sown in 2007-2010 with the first phase of the project, has now grown into actually a big tree with many branches. This tree, BETIC, or Biomedical Engineering and Technology Incubation Center at IIT Bombay, with 7 other institutions, engineering as well as medical across Maharashtra, who are now developing many more different types of medical devices, affordable, reliable, suitable for the local population.
But now we have at least reached the stage of clinical trial, and hopefully in another couple of years we would have these implants functioning well into our patients. And I want to see the day where I choose an Indian implant not because it is cheap, but because it's the best implant in the world.
And this is an example how we can bring together the exceptional capabilities that exist in different organizations, but they are complementary to one another. And if you synergize them, and then of course you are able to make world-class products.
So we've seen how research-led innovation can happen. We had nearly 6 to 7 PhD students working on that project. We had nearly 20 to 30 MTech students working on that. And we had a whole teams of doctors from AIIMS, doctors from Chandigarh, doctors from different hospitals, as well as we had the NFTDC, as you've seen, supporting us on the development. So now, I would like to now, quickly, rig up our valleys by showing you research-led innovation by taking an example of a chair. For example, here, see, if research is happening for chair design, the first valley is the first pitfall where we are talking about the new design. If it is a plastic chair, you can look at the plastic rheology. You can make the plastic in such a way that you can do research in plastics to make it very strong. You can have additives in plastic to make it strong. And from research, if you start building a product, you'll be able to come up with a very low cost and very high quality product. And that's what is the design, the combination of design, engineering design, and developmental design to come up with the aspect. So from design, then you go to the next pitfall. Now we increase our pitfalls. We're starting research as a first pitfall, where you need to really bring that research domain into your level of work. So the second pitfall, you have the design to prototype as usual. Then you can see how we are building the prototype. And in the third pitfall, you have the prototype to pilot production. That's also very clearly shown over here. A good example of how a lot of times a lot of failure happens by at the pitfalls, and the product never sees the light of the day. And then you have the pilot production, and then finally you have the mass production. And when after pilot production you have user testing, and then you take it to mass production. So now we're talking about research-led innovation. If you have to do disruptive, you need research-led innovation. The Z-line petrol pump was not disruptive. It was like the same segment, but one step ahead innovation. But in disruptive innovation, you come up with like flow metering. You don't meter by positive displacement pump, but you meter by flow. That's a disruptive technology. That needs research. And I'm very glad to say that our Department of Mechanical Engineering has hydraulics professors who work on flow metering, and we're going to use their strength to come up with the next generation petrol pump. Thank you very much for being with us.